everybody! Let's take a look at another two-dimensional kinematics vectors problem. Example 5. The components of a vector v can be written vx, vy, vz. What are the components and length of a vector which is the sum of the two vectors v1 and v2 whose components are 7.0, minus 2.7, 0.0 and 4.9, negative 9.1, negative 3.4. So this is what we're dealing with. Okay, so we're trying to find this v. Okay, v is the sum of v1 and v2, and we're given the components of v1 and v2 right here. So we just have to add those two vectors together, and we'll get v. Okay, and v is going to have the three parts: vx, vy, and vz. Okay, so our first step is to declare the following statement, and that is that v, the vector that we're looking for, is the sum of v1 and v2. And just like in the previous vector examples, remember this is vector addition, so we cannot linearly add these two together. And the fact is, v1 and v2 are actually vectors, right? They have components, x, y, z components. Okay, so if we actually write in these values, you've got a 7.0 minus 2.7, 0.0 for v1, and to that we're adding 4.9, minus 9.1, and minus 3.4. Okay. Now something that you need to make really clear is that while v1 and v2 each have x, y, z components, so does v itself. V itself has an x component, a y component, and a z component. And you have to make sure you keep all three parts straight because they're different. For example, what you're going to do, because this is addition, you're going to add all the x values in order to get the x value on the left. For the y, you're going to add the y values in order to get this place for the y. And for the z, you're going to add the z values in order to get the z value on the left. Okay? So you got to make sure you keep those straight. In other words, for our first part right here, so let's just write our three components here. For x, we've got 7.0 plus 4.9. That gives us 11.9. Okay, so there's our x value. Okay, so now for y, negative 2.7 minus 9.1 is negative 11.8. Really close there. Okay, and finally for z, 0.0 minus 3.4 is, well, minus 3.4. Okay, so those are your x, y, and z values. That is the vector v. Okay, so that would be answering the part of the question asking for the components of v. Now, it also asks you for the length, right? So think back, how do you find the length of a vector? Okay. Length implies the magnitude, right? Length is a scalar quantity, so we're going to look at the absolute value of this vector right here, this vector v. So let's go ahead and do that right now. Okay, so v is 11.9, negative 11.8, negative 3.4. Then this is how we find the length. You take the absolute value of the vector v. And we take absolute value by taking the sum of the squares of all of the entries and then taking the square root of all of them. This is just like Pythagorean theorem, except in 3 dimensions. Okay, so let's do this. 11.9 squared plus negative 11.8 squared plus negative 3.4 squared. Okay, so underneath that radical sign, you're going to get 292.41. And when you simplify that, the square root of that v, or the absolute value of v rather, is equal to 17.1. Okay, now one thing here. First thing is that the absolute value of v, you see how we've got the little arrow on the v? The arrow again implies that it's a vector. It's something that has both magnitude and direction. And then when we put these absolute value symbols next to it, or around it rather, it gives it a scalar meaning. But instead of doing this, we can just write this as v without the arrow. That implies that it's the scalar quantity. Now, as with every other question that we've done up to this point, we have to make sure that we account for sig figs, right? So we've got a 4.9, 9.1, 3.4, you know, ignoring the signs, 7.0, negative 2.7, 0.0. So we've got, well, 2 sig figs in all of those quantities. So let's just use 2 sig figs to keep it accurate. So if we round this to 2 sig figs, you're going to get, okay, that the length of the vector is 17. And there you have it. You've got the components up here, and you've got the length of the vector down here, which is 17. And that's it for this video, guys. If you enjoyed it, be sure to give that like button a click and subscribe to this channel so that you never miss a video from me. Thank you, guys, and I'll see you in the next video.